Hey guys, this is a 1.3 notes. It's on midpoint and distance. We'll start off with a little warm up. We have a little sketch on the right, and A says Latanya wants to hang a picture on the center of the wall AB. So we have point A right here and B right here. So we're trying to find halfway through. So at what point should she send her the picture? So, right. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 spots from A to B, right? So we want to be halfway in between. So halfway in between 11 would be 5.5. Okay. So from A to B, right? So halfway in between them would be 5.5. So 1, 2, 3, 4, 5.5 would be right here. Okay. Now we just got to figure out what point that is. So if we look, it's at 6.5 on our x-axis, and it's at 10 on our y. So, all right, we found it by just kind of counting. Okay. So we were able to count, right? It's 5.5 from halfway in between A and B, which is 6.510. Right. Now, let's look at C and D, right? We have sort of a diagonal, okay? So we can't necessarily see what the midpoint is, so we could maybe guess and check or things like that, right? But so if I was to guess, I'd guess around here maybe, okay? Now let's look, right? If we go over 1, down 2, over 1, up 2, right, we can see this should be our midpoint, okay? But this is kind of just a guess and check way. So that point right there is at 10.7. So 10.7 would be halfway in between them, right? And halfway is what we call the midpoint. Now, obviously, we use guess and check and we use counting for one of them, but we can use a general formula, which is the midpoint. Right, so the midpoint would be a point on a segment that divides it into two congruent. Remember, congruent from last section means almost like the same size. So two congruent segments. Okay. Now, say we have 2 points, x1, y1, and point x2, y2. Right? Our midpoint formula comes halfway in between the coordinates. So essentially, we're going to take the average of x coordinates, and y coordinates. And that's going to give us our midpoint. So our formula, so the midpoint formula is equal to our x point is going to be our x1 plus x2 and divided by 2, right? Because it's the average. We have 2 points, so we divide it by 2, and we get the average, and then our y1 plus y2 divided by 2, right? And that is what gives us our midpoint. So if we think back to that problem AB, so example, right, that AB, that A was at 110 and B, oops, oh, all right, I'll rewrite that, 110 and B was at 1210. Right, this is your x1, y1, x2, y2. So our midpoint, right, was 1 plus 12 over 2, and 10 plus 10 over 2. And if you reduce them, you get 13 over 2 and 20 over 2, which equals 6.510, right? And that's what we got for a midpoint for part A. All right. So that's how we find our midpoint. It's just this formula. Very simple. Take the two x's, add them up, divide them by 2. Two y's, add them up, divide them by 2. All right, now we're going to go on to a Pythagorean theorem review. So first off, hopefully we remember what our Pythagorean theorem is, right? This is our hypotenuse, right? And then we have our two legs, A and B, okay? So, right, the hypotenuse is always the opposite side of our right angle, right? And our Pythagorean theorem is a squared plus b squared equals c squared. All right, so c is your hypotenuse, and this is for only right triangles. All right, and that's our Pythagorean theorem. Okay, the reason we're doing the Pythagorean theorem as a review is because we can actually derive our distance formula from this Pythagorean theorem, and then we'll figure out how we got our distance formula. All right, so we're going to use the Pythagorean theorem to derive our distance formula. Okay, so we're going to label our hypotenuse as D. Okay, instead of C, it's going to be D. Right. Then our B, right? So this distance here, right? So this is C, right? Our distance for B, right? We're going straight up to down, right? So that would be our y2 coordinate, right? And then if we subtract our y1 coordinate from it, then we get this distance of B, okay? So this is what we're going to use for B. And then this one, right, we're going left to right. So we're going to use the x1 and y1, x2 coordinate. So, right, this is normally our A. And we're going to do, now for A, it's going to be x2 minus x1, right? And that's the distance for A. Okay, so we're going to use D for C, y2 minus y1 for B, and x2 minus x1 for A. Okay, so we're going to write out our a squared plus b squared equals c squared. And now, right, what we're going to do is substitute in D, substitute in this, and this for our original value. So A we said was x squared minus x to the first, right? And all of that is squared plus, and then B we're going to plug in this, right? Y2 minus y1 squared, because B is squared, and then C we said was D squared. Okay, now, right, D is what we're solving for, right? So to solve for D, to get it just D instead of D squared, we need to take the square root of both sides. Okay, square root both sides, and then we get square root of x2 minus x1 squared plus y2 minus y1 squared, and that's equal to just D, because square root of D squared is just D. And this is our distance formula. Okay, so we get our distance formula from using the Pythagorean theorem. Okay, you're not going to have to remember how to derive it, but I did want to show you how we get our distance formula. So now I'm going to, if you flip the page, I'm going to list the two formulas that we're going to use in this section that we just kind of figured out on our own. So again, right, these are the big things. So our midpoint formula is the average of our x's. Doesn't matter if you do x1 or x2 first because it's adding, so order doesn't matter. But the order does matter in the distance formula because you're subtracting. Right, so the midpoint is add the x's, divide by 2, add the y's, divide by 2, and you'll get your point for the midpoint. Now our distance formula, we said, is the square root of x2 minus x1 squared plus y2 minus y1 squared. All right, so these are the two formulas that we're going to focus on in this section in order to solve for midpoint or solve for distance. So let's look at an example of finding a midpoint of point A and point B. So what we're going to do, right, is use our midpoint formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, so we can label this x1, y1, x2, y2. All right, so plug them in. We get -3 plus 4. Make sure you're adding just the x's first. All right, -3 plus 4 over 2. And then our y's are 2 plus -2 over 2. All right, so then we reduce, we get 1/2. And then we get 0 over 2, which you can write as 0.50. All right, or you could leave as 1/2 0. Either way is fine. Okay. Now we're going to move on to something called the last piece, which is partitions. So we're going to find like a certain distance from one point to the other, but it's not going to be necessarily the midpoint. It could be like 2/3 of the distance, or 3/5, or 5/6 of the distance from one point to the other. Okay, so this is an example of a partition. We're finding 3/5 of the way from A to B. So the order matters, right? So that means we're going 3/5. So we're going to try and find something around here-ish, right? We want to find 3/5 from A to B, right? If it's a B to A, it'd be somewhere down here, right? But we're not going that way. We're going from A to B. Okay. So right, what we're going to do is first we need to find the x direction. Okay, so we need to find 3/5 of the way from A to B's x direction. Okay, so that's how we start off. So I'm going to start off with the x direction, and then we'll find the y direction, and then we'll be able to find that point that is 3/5 of the way. Okay, so to find the x direction, we find the total distance. Okay, so the total distance, to do that, is we take the absolute value of our x2 minus x1, right? Our x2 is 13, right? This is x2. Our x1 is 3. Right, so 13 minus 3, absolute value of it is 10. Okay, now what we need to do is take this 3/5 right here and multiply it by that 10, or that total distance. Okay, so 3/5 times 10 gives you 30 over 5, which is 6. Okay, so our total distance we're going from A, right, is 6. So we need to add this 6 to our x value for A. Okay, so we're going 6 units right from A. Right, so since we're going 6 units right from A, our coordinate would be, right, 3 plus 6, which is 9. So this is our x coordinate. Okay, is 9. Now we need to do the same thing for our y direction. Okay, so find the total distance. right? Instead, it's our y2 minus y1. All right, so y2 is 11, right? y1 is -4, so 11 minus -4. Absolute value of that, so it's 11 plus 4, which is 15. All right, so our total distance is 15. We need to multiply it by 3/5. All right, so we get 45 over 5, which is 9. So we need to add 9 units to our A's Y value, right? So 9 units up from A, right? So our -4, so -4 plus 9 gives us 5, right? So this is our Y coordinate, is 5. So, right, our answer, right, 3/5 the way from A to B is equal to, right, our X coordinate was 9, our Y coordinate was 5. Okay. All right, so that's a partition. We did a midpoint, and our last one is a real world example where we use that distance formula. All right, so we're going to use the distance formula because it says what is the total distance of the traveled ball. So it says a pitcher throws a ball to the batter who hits it to the shortstop. If the ball travels in a straight line between each, what is the total distance traveled by the ball? Okay, so our first thing is we need to find our distance from our pitcher to our batter, right? We need to find this distance right here. Okay, so our pitcher is at 4.5. Oh, it's kind of light. I'm going to write it in black so we can see it better. This is 4.5. Our batter is at 0.0. And then the next one we need to find is from our batter to shortstop, right? Because he hits it there. So our shortstop is at 5.10, and our batter again is at 0.0. So we'll find the distance from pitcher to batter and then add it to the distance from batter to shortstop. All right, so remember our distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so let's do pitcher to batter. All right, so our pitcher is at 4.5. So that's our x1, y1. And our batter's at 0.0. So that's our x2, y2. So distance equals square root. X2 is 0 minus x1, which is 4, squared, plus y2, which is 0, minus y1, which is 5, squared. Okay. Now we get -4 squared, right? Anything squared becomes positive, so it becomes 16. Right? Oh, crap. I'm sorry. Our x1 and y1 are both 5. Right, so messed up on that a little bit. So let's fix this up. All right, this is 5, 5. I apologize for that. So we get 25 plus 25, right? -5 squared is 25. -5 squared is 25. Add them up, we get square root of 50. Right. Now, if you take the square root of 50 in your calculator, you're going to get approximately 7.07. Okay. Next one, right? So that's 7.7 units, 0.7 units. Our next one is batter to shortstop. All right, batter to shortstop. So batter is again 0, 0. So that's our X1, Y1. Shortstop is at 5, 10. So that's our X2, Y2. So let's use our distance formula. Our X2 is 5 minus 0 squared plus 10 minus 0 squared. We get square root of 5 minus 0 is 5, squared is 25. 10 minus 0 is 10, squared is 100. So we get square root of 125, which is approximately 11.18 units. Okay. All right. Normally, right, if we were just finding the distance, it'd be we would just add these up, right? So distance is 7.07 plus 11.18, which gives us 18.25 units. But, right, if we read the last part of the question, it says round your answer to the nearest tenth of a foot. Well, if we look down here, it says 1 foot equals, 1 unit equals 9 feet. So we have 18.25 units. We want to figure out how many feet, right? So if 1 unit equals 9 feet, if we multiply this by 9 feet, we'll get the total amount of feet, right, which is equal to 164.25, right, which they tell us nearest tenth, so 164.3 feet. Okay, so that's a real world example. That's why you had to just be careful about this unit. 1 unit equaled 9 feet. But most of the time, if you're finding distance, you're just going to use these parts right here. All right, guys, that's the end of the notes. If you have any questions, let me know.